We've now looked at the four major operations: addition, subtraction, multiplication, and division, and we've also looked at simplifying complex rational expressions. At this point, you just need to be able to tackle whatever operation comes your way. So on this last page of notes, I have 4 examples just randomly put in, and then I'm going to have you check some of the answers either numerically or with a graph. So one thing, when you're just told and you get one of these fractions in a particular class, you need to really pay attention to what the operation is. What is it saying to do to the fractions? In this first example, a plus b over a minus b plus b over a plus b, we're adding. It's important to note that because adding is very different than what's happening in the second one, which is dividing. You use different techniques if you're adding versus dividing. With adding, we need a common denominator. So if I go back to this addition problem, I need to look for a common denominator, which unfortunately I don't have one right now. Luckily, there isn't anything I can factor, so that simplifies things. A plus minus b is factored, a plus b is factored. So my LCD is going to be the product of them, the two of them, because they have nothing in common. I put in my first denominator and then add in the other factor the other one doesn't have. So remember, when your denominators have no factors in common, you just use their product. So I'm going to have this as my denominator for both fractions. So if you want to, you can immediately write out the denominators, and then we can go back and fix the numerators up. Now with the first numerator, I have a plus b, and I adjusted the denominator with this a plus b, so I actually need to multiply that by a plus b as well. Be careful though, you're multiplying all of the original numerator by all of that new factor a plus b. So make sure you multiply it all out. In the second fraction, I have a numerator of b, and what I ended up extra in the denominator was a minus b, so I'm going to multiply b by a minus b. So now I have a common denominator. I've adjusted the numerators, and I have a minus b times a plus b as my common denominator. I need to add the numerators now. When I add, I need to add after multiplication occurs. So I need to multiply or FOIL out this first numerator as well as multiply out the second numerator and add them into the numerator. So FOILing out the first one, a squared plus ab for the outside, inside ab, and last would be b squared. And then adding to that, b distributed into a minus b. So I'd have plus ab minus b squared. Extend my fraction by there. Next, collect like terms. We've got an a squared in the numerator. We've got 3 ab's, so plus 3ab, and the b squares actually add up to 0. My denominator is still that common denominator of a minus b times a plus b. Because I've simplified the numerator now, I'm done with the fraction for now unless there's a common factor between the numerator and denominator. The numerator does have an a in common, and you can try to factor it out. But as I factor it, notice it doesn't give me something that is exactly the same as in the denominator. My factors are all different. A is not in the denominator as an individual factor. I have a minus b and I have a plus b, but not a. So either of these last two results would be proper answers for this addition problem. Either one would work. We didn't cancel anything, so we do not have to list out domain restrictions. In our division problem to the right, we have one fraction divided by another. Remember, when we divide, we flip and multiply. We do not need common denominators. So I'm going to flip and multiply these fractions, but to save me some time, I'm also going to factor as I go because that's part of how we simplify multiplication problems. So in my first numerator, x squared plus x minus 12, I'm going to factor that to the product of two binomials. X, I think I want to use plus 4 and x minus 3. Double check that. Yes, that does give me a plus x and a minus 12. In the denominator, I know I'm going to have 2x times x to give me 2x squared. And then factoring the negative 5 to get so that I end up in the long run with a -9. I think I want the -5 here to multiply the 2x, so I get a -10. And then if I add 1x, that gives me everything back when I multiply it. I used trial and error there, but you could certainly use the AC method on some scratch paper and throw your final result back in. Remember, when you're using the AC method or trial and error with these rational expressions, do it on scratch paper and bring back your final factored result into the work you're shown. In the second fraction, because we were dividing, we're going to flip to make this multiplication. So my numerator ends up having 2x squared minus 7x minus 4 in it, and I'm going to factor that. 2x times x again. I'm going to use trial and error and use a -4 here and a +1. Multiplying that back out, it does give me -7x minus 4, so that looks good. And then my denominator, notice, is not written in descending order, so I'm going to write it in descending order, and there's that negative in front, so that means it's a negative factor. As I go to finish factoring this denominator, which I still need to do, one of the things you can look for is anything that you could cancel and save yourself writing work. For instance, 2x plus 1 is the same in both of those situations, so I could cancel that. Let me write down what's left. X plus 4 times x minus 3, left in the first fraction, over x minus 5 times x minus 4. And then we have a negative we can factor out. I'm left with an x squared minus 16, which is a difference of squares, so I can factor that even further. So my first fraction isn't changing yet. I still need to factor my second fraction's denominator. So I have x minus 4 in the top, and then -1 times x plus 4 times x minus 4, because x squared minus 16 was a difference of squares. Now looking at what's left, I have an x minus 4 that can be canceled in my second fraction, an x plus 4 that cancels numerator to denominator in the first and second fractions, and that's it. All of my factors that are left, and x minus 5 is its own factor, are different. So what I'm left with in the numerator is x minus 3 by itself, and the denominator, -1, which I'll put out front, times the quantity x minus 5. Now, often that -1 will be written up front as just a negative in front of the fraction. Yeah, it's very common to see. You don't have to. I would accept this one or this one. But either way, you should show domain restrictions. So either way, we do need to show what x, because we canceled in several different places, what x cannot be. So x cannot be, our first cancellation at the very top was 2x plus 1, so x cannot be -1/2. What else can it be? Another calculation was here at x plus 4, so x cannot be -4. And we also canceled x minus 4 here, so x cannot be 4. So it turns out we had 3 domain restrictions on this problem.